I'd like to add my welcome to everyone who's here today, students, faculty and staff, retirees, alumni, parents, and other special guests. As I begin my 28th year at IMSA, I'm honored to speak for the first time at an IMSA convocation. I recall with fondness past convocations, remarks by Anthony's predecessors, talks by Dr. Marshall, Dr. McLaren, and Dr. McGee, convocation addresses by notable IMSA alumni, and beautiful music by our talented alumni and faculty. Convocation, the formal beginning of a new academic year, is a special occasion, one of the few where we're all together and where we see evidence that we can, in fact, clean up well. So my short talk this morning is titled Interstellar Space, Broken Bones, and IMSA. There are connections. This summer, I was fascinated by two STEM stories in the news. One about a little spacecraft, and two about a prototype 3D printed brace for fixing broken bones. Each prompted me to reflect on the marvels of science, technology, engineering, and mathematics when used well for exploration, discovery, and application. Each also prompted me to reflect on IMSA innovation, past, present, and future. Both kinds of innovation. One, sustaining innovation, where the emphasis is on improving existing products in ways that mainstream customers value. And two, disruptive innovation, where the emphasis is on creating new products that mainstream customers may not want, at least initially, and the status quo and the naysayers may resist feverishly, but some marginal or new segment will value it and adopt it, and in time, so might many others, and in time, it might be the new mainstream. First, a few words about Voyager 1. NASA launched this probe in September 1977 when I was starting my sophomore year in college, just a little older than IMSA students today. Basically, its mission was to explore Jupiter and Saturn, Saturn's rings, and the larger moons of the two planets, and that was pretty much it. But thanks to its innovative design features and the engineers who continued to innovate ongoing operations, Voyager 1 kept going and going. And in 1990, its cameras pointed back toward the sun and the planets, taking the first picture of our solar system. And in 2004, it crossed the termination shock. And this summer, it's the farthest man-made object from Earth, now traveling in a previously unknown region of space. Voyager 1 is in extended mission now, investigating the boundaries of the solar system, the heliosphere, and interstellar space, the space between the stars, beyond our sun's sphere of influence. Today, years beyond its intended life and original mission, Voyager 1 is still sending scientific information through NASA's Deep Space Network. Voyager 1 has explored grandly, innovating along the way, and in our own way, so have we. Voyager 1 carries messages from Earth on a gold-plated copper phonograph record of images and sounds, including a playlist of 27 songs, in case it finds aliens out there or aliens find it. You can listen to the playlist on goldenrecord.org. We, IMSA, carry messages from Aurora, in case we find kindred souls out there. Thankfully, we have found some, and find more we will. I think of Voyager 1 as the little spacecraft that could. I think of IMSA as the little teaching and learning laboratory for imagination and inquiry that could. We both are in the business of sustaining innovation, improving our services in ways that many science and education customers value. And then there are the 3D printed casts. In the words of one headline this summer, so cool that you'll almost want to break a bone. Well, about 6 million people break their bones each year, according to the American Academy of Orthopedic Surgeons. Finding new ways to accelerate the healing process for fractures is a big priority in orthopedic medicine, but basically, cast technology hasn't innovated much in 50 years. Now, an industrial design grad student in New Zealand has created a prototype of an exoskeletal brace for fixing broken bones using a 3D printer and nylon plastic. He modeled it after nature's honeycomb structure that forms the inner tissue of a bone. A 3D printed cast just might become a disruptive medical device, doing away with the stinky, sweaty plaster and fiberglass casts we know now, at least for certain types of broken bones. The concept is this: a person breaks a bone and goes to the ER. The doctor assesses the damage with an X-ray, makes a 3D scan of the limb, and with a 3D printer, prints out a made-to-order cast called the Cortex and snaps it into place. The patient leaves with a sleek, durable, waterproof, superhero-looking cast. Adults can jump right in the shower, and kids will think they really are Spider-Man. 3D printed casts, perhaps there'll even be a do-your-own-at-home version, are examples of disruptive innovation, new medical technology and treatment that are disrupting the status quo. In order for this cool concept to be sold as a product in the US, it will have to get the FDA's blessing. And although casts are not heavily regulated, it's unknown how much scrutiny the radical new design of the Cortex will receive. Still, I bet some people are paying attention, and good for them. Absent sustaining and disruptive innovation, interstellar space remains out of reach, and stinky, sweaty casts win. Also, we don't have iPhones, or Wi-Fi, or PayPal, or Tesla, or CVS Minute Clinics, or IMSA. Through the years, IMSA, some IMSA programs and services, and some IMSA people have been in the business of innovation in STEM teaching, learning, and talent development, and in other areas, more often sustaining innovations and occasionally disruptive ones. We need both kinds. We need faculty, staff, and students who are sustaining innovators, people who improve our existing products, services, programs, structures, and methods in ways that mainstream customers and markets today value. We also need faculty, staff, and students who are disruptive innovators, people who create new products, services, programs, structures, and methods that mainstream customers today may not want, at least initially, but early adopters will value and go to the future with them, opening new markets. I hope Voyager 1 finds some really cool stuff in interstellar space. And while I certainly don't wish broken bones on anyone, I hope the Cortex works and becomes a game changer. And I have hopes, high hopes for IMSA. Late last spring, I had an invigorating conversation with Anthony and Winesh, our student council president and vice president. And by the end, we were ready to blow up traditional high school requirements and transcripts and replace them with fundamentally different ways of organizing learning experiences, assessing achievement, and awarding credit. These guys are sustaining and disruptive innovation thinkers. We should pay attention. For a while now, I've heard a number of people wonder out loud if IMSA is coasting, if our creative best days are behind us, if we're becoming too mainstream, too set in our ways, too traditional. If that's true, and even if it's not, let's take this year, this moment in time, to alter our script a bit and throw in a plot twist or two. Let's channel innovation mojo worthy of IMSA's storied past and our extraordinary future potential. Are you with me?
We are with you.
Thank you. And thank you, IMSA Titans, for all you will do to make this a successful year of 3 I's: imagination, inquiry, and innovation. Let me close by quoting my friend and a longtime RC here at IMSA, Brian Quinby, who is seriously ill now and undergoing treatments in a hospital in Thailand, hoping to grow strong enough to return to his family in the U.S. Brian often said we didn't need a handbook with a lot of rules. Each of us just needed to do these 3 things well: take care of yourself, take care of each other, take care of this place, for us and for you, Brian.